Hello, everybody. My name is Sylvain Rochon, and I am the Paradise Engineer. Today, we're going to talk about the value of space exploration. Now, if you're a curious person like I am, you think there's inherent value in exploring space, just like that, because we want to know what's out there. We want to know what exists. Are there aliens out there? Are there habitable planets? What's near us? What's far? Black holes, dark matter, all these things are curiosities. But on a practical point of view, a lot of people just are not that curious, and they wonder, like, why are we spending all that money to explore space? And there doesn't seem to be any value to it in our daily lives. Like, there's wars, there's famine, there's all sorts of problems here. We could spend that money over here, right? It's a valid argument. And so I wrote this article to detail what exactly is the value of space exploration to us, like beyond the curiosity. Because there is, I guess, value in pure research and just a small number of people on the planet that are extremely curious about such things and to invest some money in it. But like the detractors say, I mean, there's bigger issues here that are immediately invisible that we should be fixing. So first off, let's talk about budgets, because it's all about how we spend our money. If we look at the 2019 NASA, we're going to talk about the US as an example, okay? Because there's lots of stuff going on everywhere. But the US are doing a lot of really cool things right now, and we know more about that than what's going on inside China, unfortunately. And there are part of the race, believe me. Anyhow, NASA's budget is about 0.5% of the federal budget of the US. That's in 2019. So it's not a huge chunk. Still, 0.5% of, what is it, like $13 trillion or something like that. I mean, it's still a pretty big number. It's in the billions, pretty high too. So why are we investing that? I mean, it could be like 0.2%, right? It could be less, just to assuage our curiosity of us nerds. And part of the reason why it's a semi-big number, I guess, at 0.5% of budget, is that the current administration, the Trump administration, does want to put a man on the moon by, I believe, 2024. Another person on the moon. And that's not in a vacuum. I mean, the Chinese want to do it. They're planning to do it a bit later. The US original plan was 2028, and Trump wants 2024, assuming that, because he wants it by the end of his second term, assuming he does get reelected for that at all. So it's a political play, of course, but it's also like this Chinese-Russia kind of competition, just like the space race of the 60s in a way against Russia at the time, because both of them want to put boots on the moon. But there's also some commercial interests, some private companies that want to do something similar. So you got to wonder, well, these private companies like Elon Musk's SpaceX and Jeff Bezos's Blue Origin projects, these projects are about putting devices, equipment, and people on the moon. You got to wonder why. What's the commercial interest to put something on the moon? They must have some value. They must see some financial value that's fairly direct doing that. Because normally the amount of money that needs to be spent just to put something in orbit is astronomical. So you have to have some return on investment. Now, setting off some satellites that have like GPS, telecommunication, that's clear value. They actually get money back. They earn money from companies that want their satellite up to offer services. So inherently, they just upcharge whatever the cost of sending something in suborbital orbit, sub-Earth orbit. You have the terminology wrong. Anyway, and they make money off of that. And indeed, these companies like SpaceX and Blue Origin, especially SpaceX in this case, that's how they finance some of their activities. It's by sending satellites up, right? But they do have plans to go, in the case of SpaceX, they do have plans to send some people to the moon and people Mars specifically to create colonies, sustainable colonies. In the case of Blue Origin, uh, I mean, their interest seems to be not as much putting satellites into orbit, although they could. It's more about point-to-point Earth transportation using suborbital paths. So going to live at low Earth orbit-ish, and then landing somewhere else, because that allows you to go really, really fast. So it's going from one end to the globe basically in about an hour or something crazy like that. That has value if the costs can be brought down and safety concerns are alleviated and so on and so on. So that's the short-term plan for Blue Origin. But also in 2019, they just launched this idea of a lander. So it's a rocket with a lander module to land on the moon, with the purpose of specifically to bring equipment and materials to the tune of a few tons, like I think 6.5 tons, something similar to that, to the moon, so that stuff can happen there. And the long-term purpose of that particular lander is to allow permanent residence and sustainable colonies on the moon, because you continuously would need to bring resources there, food especially, because if you establish some kind of habitable colony on the moon, of course you want to kind of become self-sufficient using the moon's resources, but that takes time, and in the meantime you have to send all this equipment over and constantly kind of bring things over. And whoever's building the base, whether it's SpaceX or the Trump government or whoever else afterwards, well, they'll need that kind of technology refined and specifically created for that. So these are private interests that have dollars in mind. But again, it goes back to question, why would we even have a base on the moon aside from curiosity and exploration, which costs money but doesn't have any direct returns? Well, the point is, no direct return, but a lot of indirect commercial returns. Since we've been out there, the space program financed by governments, because there was no commercial interest in going into space, well, there's been a whole bunch of inventions and spin-offs that were created specifically to handle the challenges of space travel, suborbital, low Earth orbit, satellites, and all this. Satellites being one of the byproducts of the space program, in fact, and because of the knowledge of and understanding of how things work in orbit and how things kind of stay in the air and the calculations and everything, well, that allowed the satellites to actually exist. So that's one big element that we're definitely taking advantage of today, and more so as we move forward. But there's all these other spin-offs, practical things like camera phones, like small phones. NASA needed to invent small phones because payloads and weight is super important, because that's where all the cost is. You're bringing weight out of the atmosphere, out of the gravity well, for example. So they had to invent very small phones, miniaturization of phones, cameras. And well, that miniaturization ended up into smartphones and other applications where there was no interest in that at the time. Now it's commonplace. The CAT scans, again, that is spin-off. Scratch resistant lenses, LEDs, light emitting diodes, low energy, no heat emitted, but it's still a light source. So you bring that into space. That's super efficient. Landmine removal, athletic shoes, the materials for athletic shoes that are kind of stretchy. The foil blankets that we see sometimes for emergency, water purification systems, dust busters, like small portable vacuums. Again, big vacuums don't work so much in space. You need to be able to hold that in your hands and and vacuum things out of the air, because there's no gravity. Everything floats around. Ear thermometers, home insulation, the Jaws of Life, that big machine that gets people out of wrecks. That was invented as part of the robotics of space exploration and the ISS. Wireless headsets, memory foam, freeze-dried food, bringing food that doesn't weigh a whole lot, important for space travel. But now we have that here too, because it is also practical for earthly transportation, even though it's less of a problem. Adjustable smoke detectors, baby formula, artificial limbs, computer mouse was an invention that for practical purpose along with computers. And portable computers even on their own were conceived, for space travel, and then they were commercialized down here because people thought, well, that's a great idea for space, but we want to be able to just carry our computers around too. And again, miniaturization, waste savings, and things like that. So you have all these things, including also, of course, the satellites and telecommunications and GPS. All these things are ours because we attempted to go to space and we did the efforts to actually conquer space. And now we reap the benefits from it, but it's a tangential. It's not direct benefit. So as we continue to push on, like a moon base, or that's other challenges for engineers. They'll try to figure out, and they'll invent certain things specifically for that. But that will be able to leverage some of those inventions, those ideas here. We say, well, that's applicable here. That's applicable here. So pushing into the unknown, into uncharted territory, science-wise and engineering-wise, gives dividends. But businesses don't really depend on things that are tangential or secondary to what's going on. They want to have a real plan for revenue. So is there anything? Oh wait, before I get into the the direct benefits or the potential direct benefits of space exploration, direct commercial benefit, just to give you an idea of the costs of sending something into a low Earth orbit. So low Earth orbit is where the satellites are for telecommunication and the spy satellites and GPS, all these things. Going there takes a lot of energy. Going beyond the low Earth orbit, it doesn't take a whole lot more energy. But these numbers I'm going to give you are to reach low Earth orbit. So to go a bit beyond is going to be slightly more expensive than that, but not by much. It's not like 10 times. It's going to be a certain percentage higher. But I found this graph and this and these numbers for low Earth orbit, which is pretty close. So to give you an idea, in 1981, so that's the space shuttle era, right, where we actively started to bring cargo, like payloads, into space and satellites and the Hubble and all these things, using those shuttles. The cost to bring something in low Earth orbit was a little over $85,000 US per kilogram. Per kilogram, okay? That's pretty expensive. So if you take out your little calculator here and you go back to 1981, the space shuttle, and you want to bring yourself, like I'm 92 kilos times $85,000. So it would cost me, that's without profit, but almost $8 million to bring me into low Earth orbit. I'm nowhere near the moon yet. I'm just floating like a satellite up there. And the only place to go is down from there. I just go back to Earth. So that's really, really expensive. So these first satellites and these first pieces of equipment were super expensive to bring up. But over time, just like anything else, the cost has gone down. So if you look at the innovations, specifically SpaceX innovations with engineering, because their goal is to be as cheap as possible, because they want to get to the moon. They want to get to they want to bring lots of stuff and people to the moon and Mars. They have to bring cost rocket bottom. Well, the most recent rocket, the Falcon Heavy, which is bigger than the original Falcon, you're looking at a bit less than $1,000 per kilogram to bring something into low Earth orbits. That's 85 times lower than the price of 1981. So it's still, for me, a little bit less than $100,000 to bring me into low Earth orbit, but that's way less than 8 million. It's not affordable unless you are extremely wealthy people. You can't really afford that. But some people are booking seats for Blue Origin and also for Musk's ventures into space, because they are wealthy. $100,000, $200,000 for a trip to space to be one of the first. Yeah, cool. Like if I had that kind of money, I would probably buy my seat too, just for the sheer thrill of it. But for the common person, not very interesting. Now, the goal for 2040, this is NASA's goal, and of course, the private sector is going to compete with NASA, and they'll also collaborate, because NASA collaborates with dozens of private firms constantly to save taxpayer dollars and, you know, for practicality and expertise reasons and whatnot. They wanted to bring it down to tens of dollars per kilogram. So let's imagine, let's say, $50 per kilogram. Well, now you're actually going to low Earth orbit for like a first class seat in an airplane, the same price as a first class seat. Well, that's 20 years from now. It starts getting affordable. And then a little bit farther down the road, then it'll get just cheaper and cheaper and cheaper as we find new ways and better ways to be economical, new sources of energy, and so on. And eventually, I mean, there's a plan eventually to do a space elevator, which is a kind of, an elevator from somewhere on Earth or in high orbit that extends, because there's a couple ideas for elevators. One is the route of the elevator is on Earth and extends out to a certain height. Then from there, you can launch, using, very little energy into orbit, into outer space. So you have a little station, if you will, at the top, like a tiny station, probably not big. And then you take an elevator and you bring cargo, people, whatever you need, and then you fly. That's the concept. And the other concept would be, because the moon facing doesn't change, well, you build it on the moon with the roots on the moon, and then you extend it out towards the Earth into high altitude. Okay, that's a pretty long elevator if you do that, because there's like 360,000 kilometers between the moon and the Earth. But you could then take an airplane and then dock with the tip of it as it moves into the air. So that's, I guess, a bit trickier. And then you can go to the moon directly. And you can have like an intermediary station where you could be at the Lagrange point or some other location between moon and the Earth, and then go off into the solar system. So these are a couple of ideas that people have been tinkering with. But if we're able to do that, I mean, the cost of that elevator would be astronomical, but then it would be like super cheap to go to the moon, to do anything you want. And it wouldn't be dangerous at all. It would be way, way safer. So like, I wanted to kind of establish that, the costs of all that. And that's why we haven't been doing a whole lot of traveling to space, and companies haven't been really looking at the solar system for businesses until very recently, because it's just so costly. Now, as costs go down, thanks to some entrepreneurial spirits and NASA and other organizations around the world, then some companies are kind of thinking, okay, what is there out there that we can grab as a business model? And unfortunately, aside from the ideology of like this is Elon Musk's ideology of creating a new colony on Mars, in case the Earth blows up, to preserve humanity. That's an ideological. It's not a business plan. It's just, let's save humanity and let's spend money to do that. There's not a whole lot in the solar system that is of worth to businesses in the economy today. The planets, if you can look at the planets in the solar system, there's a variety of them. We have 8 planets total. Pluto is not a planet, it's a planetoid. So let's count it out for now. It's also so far like it's impractical, and it has this erratic orbit and super, super far. Anyhow, if you look at any one planet, it has on its surface and atmosphere, they have very much the same minerals that you'd find on Earth. And there's like regolith, for example, in the moon, which is helium-3, or it contains helium-3. And that's interesting for a nuclear reaction or fusion reactions and different type of very specific applications. But it's such low concentration. There's no viable way to extract that and bring it back. It really doesn't make a whole lot of sense. Regolith is on the surface of the moon. It's kind of deposited over in space constantly, and it doesn't really make a lot of sense to do that. And we have helium-3 here, just a slightly higher concentration on the surface of the moon. But you can get it here. Much of the surface of and atmospheres of all the planets are composed of the same materials as you'd find here, just different temperatures, different physical states, gases versus liquid, depending on the temperature. So there's no real value to go there to extract resources from the planets themselves. It's just very dangerous, very costly. Like the distances are huge. Like if you want to go to Venus, which is the closest planet that we have, it would take about 3 months with the technology we have today, approximately. And that's when the Venus is closest to the Earth, because they each have orbits, and at a certain point in time, both orbits, they're kind of sync together, and they're closest. Well, that's 3 months travel just to get there, and then Venus, it gets farther, and then eventually they're kind of on opposite sides of the solar system, which would make it too far. Now, each time that they are, the time between when they are closest, like 3 months apart in travel time, is 584 days-ish, from what I remember. So like a year and a half, a bit more than a year and a half. So you travel there, and then next time you can go there realistically, like with time, taking still 3 months, would be a year and like 2/3 later. Then you can still go back. Mars is the next closest planet, and it's twice as far. It would take 6 months to get there. And it still has the same problem. Eventually, they rotate on the other side of the sun from each other. It's super far. You can't go there, so you got to wait till the cycle comes back, and so on. So distances are really, really big problem, and there's no significant increases in speed, in sight, and in research that would really cut down on that timeline. Like we need 10, 20, 50 times faster than what we do, and there's some ideas, but nothing really practical. So planets have the same materials basically as Earth. And the materials that we have on Earth, that we have plenty, is like on water, for example. We have huge amounts of liquid water. There's water in other planets, but at lesser concentrations, but we have it here, so no biggie. And it's all, the materials are all composed of carbon, oxygen, nitrogen, hydrogen. Primarily, those are the most common elements in the universe, and our bodies and the organics. And these are the compounds you're going to find in great majority on all the planets on the surface. Now, interestingly, where we find concentrated levels of heavy metals and rare metals, well, we find that, well, not the rare metals, the heavy metals, like platinum, palladium, rhodium, things that you'd find in catalysts, in electronics, iridium, things that are very useful for modern technology. We find these small concentrations near the surface of the Earth crust. Same on the other planets, same deal. But because they're so heavy, and because of how planets are formed, these heavy elements are actually in much higher concentrations near the center of the planet. Now, it's very impractical to dig that deep to mine heavy metals on Earth. Even less practical to do that on another planet where it's the same scenario. The heavy metals are also nearer to its core. However, these metals do have a high practicality value, and they have a high, they're costly because they're fairly rare near the crust surface. And it just so happens that we have astral bodies in the solar system that used to be part of the center of planets or suns a long time ago. Those are asteroids. We happen to have a bunch of, well, I have three asteroid belts. It's been a while since I've checked that. I may be wrong. There may just be 2. I know there's at least 2. There's the Oort cloud, and then there's another one, between us and Mars, essentially. So there's a couple asteroid belts that are there. And is it near? Anyway, I may be wrong about the Mars one. It may be beyond Mars. Anyhow, there are 2 of them, perhaps 3. And asteroids, yeah, they used to be there's bits and pieces of other astral bodies like far after their formation. So a lot of asteroids actually have the exposed centers of planets to dead space. And due to all sorts of measurements, we know that some asteroids have quantities of, let's say, iridium or rhodium or platinum, palladium, and these very heavy metals that are very useful. Well, they have concentrations that are 400, 500 times, 600 times that what is found in the Earth crust or in the surface of any one planet in the solar system. And the heavier they are, the higher the percentages or the concentration is versus what we have found on the planet. Because in the planet, the heavier the element, the closest to the core, it's going to be found in high concentration. And the lighter elements, again, carbon, hydrogen, oxygen, nitrogen, and silicon, and these things in the periodic table, the lighter elements are mostly found on the surface. It's because of how the planets are formed and gravity and pressures of the formation. So presumably, there is a business case when costs go far enough down to mine asteroids for these heavy elements. So the cost calculation would be that, I mean, you're getting a 500 times more yield on the surface of an asteroid, but you have much heavier cost to leave Earth's gravity, get there, which takes a huge amount of time. Because the Oort cloud, forget about it. That's like on the edge of the solar system, it's super far. But the one that's near Mars went relatively close to the planet, to Earth. So you could send unmanned drones to mine and transport using AI and advanced technologies to mine and transport these materials back. And so the cost of transportation, making the drones and all this stuff, could it be worth it? Assuming we still need those heavy metals quite a bit in 10, 20, 30 years. Then there would be an actual direct business case to do some exploitation of the solar system. Otherwise, it's just exploration. So curiosity leads. We decide to spend a small amount of our budget to go beyond what we know. We develop and we engineer what we need to get there. We get secondary value and benefits from the inventions on Earth as we explore. And maybe there's going to be a future where we actually derive some actual value from the solar system. So in conclusion, value of space exploration, there's plenty. But I don't see any serious solar system commercial exploration going on. Exploitation, not exploration. Exploitation going on. Tourism, sure, when costs go down enough, like people want to kind of have a resort in a certain place around the moon, around planet Earth in orbit, maybe another planet, assuming we can reach, again, the distances are so far. It takes 3 days to get to the moon right now. Not too bad for a trip and to stay at a hotel or resort for a while. But going to Mars or for a vacation it's going to be a long vacation and a dangerous one too. Space being the most inhospitable environment for a human being to be in. I mean, if you're ready to eat dried food and recycled food from, guess what? From poop to a certain degree, and of course recycled water and recycled oxygen for 6 months, and without equipment failing, so that you don't fail, and then you have plants and you have growths and you have all these things to supplement in these kind of big ships that would travel you there. If you dislike that idea and that risk, and doing that for 6 months, taking that risk, well, you probably won't go. And the cost for that would be astronomical, even though, maybe the cost of leaving Earth orbit would be, first class-ish costs in 20 years or odd. Traveling for 6 months, paying for that, that's pretty big. So that's it. It's interesting to note that most of really the interesting part and what we really need and what businesses really need and can exploit is really all here on the planet Earth. there's very little that value to go anywhere else to do anything except just being curious. And I'm okay with that.